Hi guys, welcome back to Introduction to Rust. My name is Tensor. Today we're going to be writing a browser engine. So because this is a rather large project, we might end up splitting it into multiple videos, just as an FYI. A web browser engine is the portion of the web browser that works under the hood to parse the HTML, JavaScript, and CSS and translate it into forms that we can read, write, hear, etc. There are a few popular examples of browser engines. For instance, there's the Gecko engine, there's the WebKit engine, there's the Trident engine. So the browser engine includes many subcomponents. There's an HTTP client, there's an HTML parser, a CSS parser, a JavaScript engine, and many other things. Now, keep in mind that the JavaScript engine is usually composed of its own parsers, interpreters, and compilers, and those components all work together to sort of parse the web formats like HTML, CSS, and JavaScript and translate them into a layout engine or a rendering engine. Of course, our browser engine will not be a fully featured browser engine. If you look at the WebKit or the Gecko code base, you will see millions of lines of code. Even younger, more simpler browser engines like Servo, which is also written in Rust, is at least 100,000 lines of code. Where do we start with all this? Well, the best place to start is to build a module that helps us parse the DOM, or the Document Object Model. So you guys will notice that I've already created a project here. This is not a binary project, but rather a library project. We've got our lib.rs, and I've got that open. And we're going to create a file called dom.rs, and this is where we're going to have most of the logic for our DOM. Now we want our DOM module to be a part of our library module, so we're just going to come into our lib.rs and type in mod DOM. Alright, so the first thing we're going to look at inside of our DOM here is the node structure. A DOM itself is a tree of nodes. We have children field here, which is a vector of nodes, and this could be 0 or more children nodes connected to this node. So just think of it like a tree pattern. Then we have our node type. Now there are various different types of nodes, but we're only going to be dealing with 3 types in this tutorial. So the 3 types of node types that we're going to be dealing with are a node that's text with a string inside of it, a node that's an element with element data inside of it, or a node that's a comment with a string inside of it. If you look at an HTML document, a lot of the elements tend to fall in these 3 categories, though there certainly are more categories in there as well. And then our element data will be a tag name, which will be of type string, and then it will be the attributes, which will be an attr map. So an element includes a tag name and any number of attributes. So for instance, if you have a div, the div is the tag name, and then the div could have a class or an ID, and those would be the attributes. And we can store all of these attributes in an attr map, and that's what we're going to do here. So we're going to bring in the collection hash map type, and then we're going to make a simple type declaration, just going to say that the union type attr map is equivalent to a hash map with 2 strings inside of it. Now this syntax we haven't actually looked at up until now inside of Rust. This syntax is sort of like creating a synonym. So for instance, every single time you see attr map, you could just replace it with this hash map type. Other examples would be to create, like for instance, a type integer that is always an I32. Now of course we also want some basic methods for each of our data structures. So let's create a method that allows us to instantiate a new node. And this method is exactly as you'd expect. We're just going to input the node type and the children, and then we're just going to put them inside of a node object like this. We also want to implement debug for nodes so that we can easily see it inside of our browser or inside of our terminal. For this, we need to bring in the standard library fmt, and then we need to create our fmt function here. So this takes in a reference to self, a reference to a mutable fmt formatter, and returns an fmt result. And then we'll just simply call our write macro, put in f, then put in a debug flag, and then call self.nodeType. So this will print out the actual node type. Now this is throwing an error, and that's because debug hasn't been implemented for our node type enum either. Our implementation for debug for our node type will simply have our fmt function match on self, and for node type text or node type comment, it will be just writing it with a simple write statement, and for node type element, we'll be writing it with our debug flag, which again will give us an error because we do not have debug implemented for element data. We will implement it for this as well. Our implementation for debug for element data is a little bit more complicated than the other two. First, we create a mutable string called attributes string, and then we want to iterate through our hash map, and this we need to turn into an iterator. Then for each value and attribute of our hash map, we want to push in this format into our string. So it will say the attribute and then the value of that attribute, and they'll be equal to one another. And then we'll use our write macro and we'll insert the tag name here and that attribute string here. Okay, so now that we have all of those debugs implemented, let's finish up by creating some methods for our element data. First, we'll create a new function. This will just take in a string type and our attr map, and then we will just instantiate an element data with the tag name and the attributes inside of it. Then we want to create a function called getID to return an element's ID. So this function will just call the attributes, which again, if you guys remember, is a hash map, and then it will look for a string called ID and get the value out from that. And then we want to create a function called getClasses, which takes in our reference to self, and this is going to push out a hash set. Now a hash set is like a hash map, except it is all keys and no values. We want a hash set where all of the quote-unquote keys are just a value slice of string type. We're just going to match on self.attributes.getClass, and if we get back an option of sum S, then we take S and we split it by its spaces, and then we collect all of those S's inside of our hash set. If we get none, then we just create a new hash set and return it as empty. Oh, and by the way, I brought in the hash set type from our collections up here with our hash map, so it's inside of our standard library collections. So before we finish this file, I also want to create a function called Prettyprint, and this is going to allow us to print out a node as well as its descendants with indentation. So we're just going to do this to make things a little bit neater for us. So our Prettyprint will just take in a reference to our node, and then it will take in an indent size, which will be uSize. First, we're going to iterate from 0 to our indent size, and then we're going to map a closure that just returns a space into a vector of strings, and this will give us the appropriate indent size for everything that we need. So then we're going to match on n.nodeType, and we're going to match through each of our node types, element, text, and comment, and we're just going to print them out in different ways. So for instance, our element, we'll print it out so that we have our indentation first, and then we'll print it out as a debug. Then for text, we'll just print out our indent and then our text, and then for comment, we'll print out our indent and then a little comment flag from HTML. I know this looks like an arrow, but these are two dashes followed by a arrow like that. So then we want to iterate through all of the child nodes in our node. So n.children, iterate, and then for each of them we're going to call our Prettyprint function recursively with our indent size being incremented by 2. Then finally we want to match on n.nodeType, and then for nodeType element we want to take out the reference to E and then just print out our indent plus our indent with the tag name inside of this here, so it'll actually look like HTML. And then for the rest of them, we just want to skip this part because they don't actually have tag names. Alright, so that's it. This is a fairly simplistic DOM implementation. A full-blown one would probably contain a lot more methods and a lot more stuff. Now that we have our DOM data structures and helper methods already set up, let's get ready to create an HTML parser. HTML has its own unique parsing algorithm. Unlike most parsers for most programming languages and file format, the HTML parsing algorithm does not reject invalid input. Instead, it uses very specific error handling instructions. This way, the various different web browsers will be able to agree on what a website should look like. Also, because non-conforming HTML has been supported since the early days of the web, it's now used in a large amount of the web pages that exist today. So we want to import from our DOM, our attr map, our element data, our node, and our node type. We also want to import our standard library iter peekable and our standard library string chars. Now these two things allow us to do some very specific things here, and I'll talk about that in a moment. Just FYI, I went back into the DOM module and I made most of these things public so that we can gain access to them inside of our HTML parser. Our HTML parser struct has a lifetime of A, and it has two fields. It has chars, which are a peekable list of characters, and then it has a node q, which is a vector of string. Now the peekable data type is essentially an iterator type. It iterates over option types, and it tells us whether or not the option has some or none. In this case, because we're iterating over characters, I want you to think of it like a character stream, and then I want you to think of our node queue like us putting our characters into strings and then passing them into a vector. So we also want to make some methods for our parser here. And of course, because we have a lifetime, we need to write it like we're writing a generic. Our first method is a new method. This will take in our HTML string and output an HTML parser. So this will just take our HTML string, turn it into a peekable iterator of characters, and also create a new vector. Next, we'll have a method called Parse Nodes. This will be the main entry point for our HTML parser. This will take our mutable selfs and output a vector of nodes. First, we'll create a new mutable vector called nodes, and then in a while loop, we will iterate through our characters while checking to see if we have some data or not. So this returns true if the option is some, and returns false if it is not. So rather than going through the specifics of this function, because it's fairly complicated, I'm just going to talk about the ideas. Because HTML can accept invalid structure and invalid syntax, what we want our methods to do is, rather than throw an error on the invalid syntax, we want them to actually correct that invalid syntax. So we have this while loop, which is iterating through all of our characters. Then we have this consume while method that we have created at the bottom here. Let's look at that first. Consume while takes in our mutable self, and then it takes in a conditional, which is a function, which we define here with this generic f. We say the function must take in a character and output a boolean. Then we create a new mutable string, and then we loop through our characters, and we use this map or function. We want to check to see if this condition is false, and if it's not, then we return default values, which in this case would be just a white space character. And then we just take the result and we push it onto our characters, and then we go to the next character and we unwrap it. And then finally we take the result and we pass it back as a string. You're going to see this repeated multiple places inside of our methods up top. And we have various helper functions here to help us actually parse the HTML characters. Some of these are fairly specific, like this is looking at double quotes, spaces, slashes, opening and closing tags, etc. And this is looking at hexadecimal characters to see if we have non-ASCII characters. And then we're checking to see, for instance, in this function, if we have a valid adder name. For this one, we're checking to see if we have a valid tag name. All right, so back up to our parse nodes function. We say self consume while, and we're checking to see if the character is white space. If it is, then we want to consume all that white space. So basically, we're just removing it from our characters. Then we're going to check to see if C is equal to an opening tag. Then we're going to move forward in our iterator, so characters.next. Then we're going to check to see if characters is a backslash. If it is, then we move forward. Then we're going to check to see if we have more white space, which we then again consume. Then we take and we bind close tag name to self.consume while is valid tag name, and this checks to see if we have a valid tag name inside of the HTML. As long as it's just a basic word, it's a valid tag name as far as we're concerned. And then we create a string, so we consume while x is not equal to the closing HTML tag, and then again we go forward through our iterator of characters, and then we want to push our closing tag name into our node queue, so our vector of string, and then break out of this while loop. So if we go back up to this if statement where we're checking to see if there's a backslash, we have an else, and this is checking to see if rather than a backslash we have a exclamation point. This would mean that we're looking at an HTML comment. So then we go to the next character, and then we push into a new method called parse comment node, which we'll look at down below. Then we have another else statement, and this else statement only occurs if we do not have the appropriate looking HTML for a comment or for a normal element. So we run this method called parse node, and we set it equal to a mutable node. Then we say our insert index is nodes.length, so we check to see what the length of our nodes are, and then we match on the node type. And if our node type is an element type, then we want to get the element data from inside of it with this ref e. And we check to see if self.nodeQ length is greater than 0. And then we can say, okay, well, the assumed tag, so the incorrect HTML mangled tag, will equal self.nodeQ remove 0. So remove the front of our node Q. And then we want to check to see if e.tagname, our element data, is not equal to our assumed tag, and then we want to append our node children to our nodes, and then we want to take our assumed tag and insert it in our node queue. Finally, after this match block, we want to insert our insert index and our node into our nodes. Then we have this other else right here. This else is saying that if we don't have a less than sign, then we want to run this method, which is parse text node, which means that we're not running into an HTML element. Instead, we're running into a block of text. And so finally, our method will just return our nodes, which is our vector of node. Our parse node method gets run, and it checks to see first if our tag name is valid. Then it parses the attributes, which is another method that we have below. Then it creates a new element data. Then it uses the parse nodes function, which is the one that we just went through, to create the children nodes. It creates the new node type of node element with the element inside of it and the children appended to it. Our parsed text node takes in a mutable reference to self and outputs a node. This first goes and says let mute text content equal a new string. Then we want to have a while loop that iterates through all of our characters and peeks inside. We want to check to see if our character is not equal to an opening HTML tag. So we want to consume all the white space. Then we want to check to see if the white space length is bigger than 0. And if it is, we want to take and push one single space into our text content string. So this is important because what it'll do is it will iterate through our text like this. It will find the white space. So these are 2 pieces of white space. It'll delete that 2 pieces and make it into 1. And it'll do that for each part. Then we want to check to see where X is not white space and it's not equal to an opening HTML tag. Push that content into our string, and then we want to create a new node for text type. Things get quite a bit more complicated for our parsed comment node method. We want to check various cases here. So this first block here is mostly for checking for the normal case where we have an actual HTML comment that looks correct. This is what a typical HTML comment will look like. So for instance, this is a comment. So we've already established that the character before the one that we're looking at right here is an opening tag. We want to see if it's followed by 2 dashes like we're looking here, 1, 2. Then we want to consume all of the string until we hit our closing tag, in which case we create our comment node with a, if we're missing one of these dashes, then we just want to consume the text immediately. Now this part is for if we have an error. If for instance we have our opening tag and then immediately after we have a closing tag, then we just want to parse that, take all the string and put it inside of our comment node. Then for this case, we're looking to see if immediately after our opening tag we have 1 dash and then we have a closing tag. We want to take everything after that and just slam it into our string as well and create a new node with it. And if it's not, then we just want to take and put a dash into our mutable string that we created up top. Then we have this huge while loop with a bunch of nested if statements. Now this will check various different error cases for our comment. I'm not going to go into the specific details. All of the code here will be on GitHub so you can look at it yourself. You can see that all the else statements simply create a proper error tag with the elements that are missing from the if statements. So our parse attributes method will create a new attribute map. Then we want to make sure that our character is not a closing tag. We want to consume the white space. Then we want to set name equal to when our attribute name is actually valid. And we also want that to be lowercase. Then we want to consume the rest of the white space. Then we want to check to see if we have an equal sign. So for instance, if we have class equals to the header, then we want to go to the next character and we want to consume all the white space. Then we want to parse that particular attribute value, so the header word, and we want to consume all the way up till the closing of the tag, as well as all this white space here. And then we'll return s, which is this header value. Otherwise, we just want to return an empty string. Then we're going to insert the name and value into our attributes map, and we're going to keep iterating through our characters, and then we're going to return our attributes, which is our attributes map. For outer value, we want to consume any white space that we're looking at currently. Then we want to match on self-char's peak, set that equal to result. And for our sum, we want to see if C is equivalent to a quote or it's equivalent to a backslash quote. Then we're going to iterate the character forward by 1. Then we're going to set ret equal to self.consume while X is not equal to C, where C is a double quote or a backslash quote. So we want to consume all of the text before we get another quote. So for instance, if we have ID equals section, section is typically surrounded by quotes. So we just want to consume the section word itself. Then we'll return ret as results. And then for anything else, we just want to go and check to see if it's a valid attribute value, and we just want to return the result. Down here is our consume while method, and then we have all of the different Boolean methods that we created to help us get through this. Alright, so that's our HTML parser. I know I kind of glossed over it a bit, and I did this on purpose because this is not really the more interesting part. If you are interested in parsers, then by all means, take a look at the source code on GitHub. It's definitely worth doing. The more important lesson here, however, is the DOM stuff and how our parser actually works. And hopefully you guys were able to understand that, even though I went through this very quickly. Alright guys, well that's it for today. Tomorrow we'll look at building our CSS and our CSS parser. I hope you enjoyed this tutorial. If you did, feel free to like and subscribe. If you have any questions or comments, feel free to leave them in the comment box below. And if you disliked it, then by all means downvote it as much as you like. Have a good night, guys.